Here we're going to look at question 40 of the ENGAA 2018 paper. In this question we're told we have an object of mass 2 kilograms, labelled x, travelling at an initial speed of 4.5 metres per second. We're then told that a force of 5 newtons is applied in the direction of motion on this mass for 3 seconds. Then, a short time later, our block x collides with a block y of mass 3 kilograms, which is initially stationary. The question then asks us, after a sticky collision where the two blocks move off together after colliding, what is the speed of our resultant mass? If you would like to have a go at this question, just pause now, otherwise let's have a go at it. So first, let's consider our block x. Now we know that this force is going to cause an acceleration on the block. And we know this because of Newton's second law, that the force on an object is equal to its mass multiplied by its acceleration. So this force is going to accelerate the block and increase its velocity. We can find the acceleration by rearranging Newton's second law to get that A equals F over m. Then, substituting in that our force is equal to 5 newtons and the mass of our block is equal to 2 kilograms, we get that our acceleration is just equal to 5 over 2 meters per second squared. So with this acceleration, we can go ahead and find the velocity of our block after it's accelerated, after our 3 seconds. Now how would we do this? Well, we could use this equation, that the final velocity of an object is equal to its initial velocity plus its acceleration multiplied by the time it accelerates for. So its final velocity is going to be equal to its initial velocity of 4.5 meters per second plus our acceleration, which is just 2.5 meters per second squared, because 5 over 2 is just 2.5, multiplied by our time period of 3 seconds. And doing this, we find that the final velocity before the collision is 12 meters per second. Now that we know this, we can go ahead and consider the actual collision. So our block x of 2 kilograms, moving at 12 meters per second, collides with the stationary block of 3 kilograms, which is just labelled as y. Then they stick together to coalesce and form a single mass, 5 kilograms, and the velocity of which I've labelled here as beta, because we're going to try and find out what that is. So how are we going to do this? Well, there's one rule which we can always try and use with collisions, and that is conservation of momentum. So we know that the momentum of a particle is just given by its mass multiplied by its velocity. So if we find the total momentum before, then this is going to be equal to the total momentum afterwards. If we go and try and set up our equation for conservation of momentum, then we find that the momentum before is just equal to the momentum of our first two objects, so our 2 kilograms multiplied by our 12 meters per second, plus our 3 kilograms multiplied by our 0 meters per second, our stationary block. And this is just equal to the momentum of our final particle, 5 kilograms multiplied by the velocity beta. Simplifying this, we find that 24 is equal to 5 beta, so dividing through by 5, we get that beta is equal to 4.8 meters per second. So this is going to correspond with answer D given in the question.